Last episode, we put every numeric column on the same ruler, but putting them on one ruler doesn't make them independent. Some are still saying the same thing twice. Let's hunt down the redundancy. Here's the suspect. In telco, total charges is roughly tenure times monthly charges. Stay longer, pay more per month. Of course, your total is high. The total mostly repeats what the other two already say. A correlation heat map makes this visible. A grid where each cell is how tightly two columns move together. Bright cells near one mean these two are basically twins. Correlation only checks two columns at a time. Multicollinearity can hide across three or more. So we use VIF, variance inflation factor. For each column it asks how well can all the other columns predict this one. A high VIF means the rest of the table already knows this column. It is redundant. Rule of thumb, above 5 is a yellow flag, above 10 is a red one. The fix is usually to drop one of the twins. Let's build the heat map and the VIF table on the train numeric columns and watch total charges light up. Spine first, load, fix total charges to numeric, split train and test stratified on churn with random state 42. We compute the correlation matrix on the train numeric columns only, tenure, monthly charges, total charges, senior citizen. Then VIF column by column, also on train. Each VIF comes from regressing one column on the others. Print the strongest correlated pair and the VIF for each column. Total charges and tenure come back tightly linked, and total charges carries the biggest VIF. The figure is the heat map with the VIF values listed beside it. The redundancy in one picture. Now we know which columns repeat each other. Next question. Out of everything that's left, which features actually help predict churn? That's feature selection. If this helped, like and subscribe for more.